Today, we're diving into the science that's hiding in plain sight. We're talking about the chemistry of solutions. And trust me, by the end of this, you'll see how everything from that can of soda on your desk to the pure water from your tap is run by a few really simple but powerful rules. So let's start with something you've probably wondered about a million times. You crack open a cold drink, you hear that amazing psst sound, you see all those bubbles, but then just a couple hours later, it's totally flat, just sugary water. What is going on there? Well, the answer starts with understanding what a solution even is. Okay, so let's get into it. Before we can solve the mystery of the fizz, we gotta get the basics down. We're going right back to square one. What are the fundamental building blocks of any solution? So, at its heart, a solution is just a super even mix of two or more things. It's blended so perfectly that you can't see the individual bits anymore. And we call these parts two things, the solute and a solvent. And figuring out which is actually pretty easy. The solvent is the main event, the one you have the most of, like the water in salt water. The solute is the thing you're adding in a smaller amount, the stuff that disappears, like the salt. So put it this way, the solvent does the dissolving, and the solute is what gets dissolved. Simple as that, right? All right, let's build on that. Because making a solution isn't just about randomly stirring things together. Oh no, it's actually all governed by these predictable scientific laws. And one of these laws is the absolute key to our whole soda mystery. And here it is, Henry's Law. Now I know, it sounds a little technical, but the idea behind it is incredibly simple. All it's saying is, the more pressure you put on top of a liquid, the more gas you can cram into it. Just think of it like you're literally squeezing those gas molecules and forcing them into the liquid. And this explains our soda can perfectly. When they bottle the soda, they use crazy high pressure to shove a ton of carbon dioxide gas into the liquid. They seal the can, and that pressure is trapped. But the second you pop that top, hiss! You've just released all that pressure. Suddenly, the liquid can't hold on to all that extra gas anymore, so the gas bolts for it, escaping as fizz and bubbles. And that, right there, is why your soda eventually goes flat. Mystery solved, it's just Henry's Law in action. Now, there's another key rule out there called Raoult's Law. And to keep it simple, it basically just says that the more of a certain ingredient you have in a mix, the more it adds to the overall pressure above that liquid. It really all comes down to proportions. Okay, now this is where solutions get really interesting. We're going to talk about something called colligative properties. It's a fancy name, but I want you to think of it as the magic of crowds. Because these properties don't care about what you've dissolved, only how much of it is in there. So here's the main takeaway. It doesn't matter if it's salt or sugar or some other weird chemical. All that matters is the number of particles you've added. It's kind of like a crowded room. The vibe in the room changes just because of the sheer number of people, not because of who those specific people are. It's all about quantity, not quality. And you see these four colligative properties everywhere, for real. You know when you see trucks salting icy roads? They're not trying to melt the ice with heat. They're using a colligative property. By adding all those salt particles, they're making it harder for the water to freeze, actually lowering its freezing point. It's the exact same idea behind antifreeze in your car. And that last one, osmotic pressure, well, that one is absolutely crucial for something we all need to survive. So let's take everything we've talked about and connect it to a really powerful piece of tech that, honestly, a lot of us have in our own homes. So how can we actually take this idea of osmotic pressure, this magic of crowds, and use it to tackle one of the world's biggest challenges, getting clean, safe drinking water? The answer is something called reverse osmosis, or RO. See, normally, water naturally wants to move from a pure area to an area with more gunk in it. But with RO, we apply a whole lot of pressure to fight that natural tendency. We literally squeeze the pure water molecules away from all the impurities, forcing them through a super fine filter. And that's the chemistry right there in your kitchen. That RO filter you might have under your sink, it's using this exact principle. It's applying pressure to push pure water through a membrane, and it leaves all the nasty stuff, the salts, the minerals, the contaminants, behind. When you really stop and think about it, it's pretty incredible. These deep, fundamental laws of chemistry, they aren't just stuck in some old textbook. They are running the show all around us, in the most ordinary and in the most important parts of our lives. So, the next time you hear a soda can fizz or you pour yourself a nice, clean glass of water, maybe you'll see the elegant chemistry that's at play. So I'll just leave you with this question. What everyday solution are you going to look at now and see something totally different?